Good afternoon, ladies and gentlemen. As you can see, I am not in your classroom today, so I'll be doing a recording for you to go through our first day of reviewing some graphing information for your state test. Now, the graphing section is kind of broken up. There's some parts where you just have to calculate given a graph, and there's some parts where you actually have to make a graph. So today we're going to just focus on the problems that you will just need to be doing some calculation. So with that being said, let's take a look at some of these questions. Now remember, this recording is on Google Classroom as well as the blank document for viewing these questions. So you should be taking notes on a separate sheet of notebook paper, the one that we've started thus far. We've done all of our other review work on, and putting your work on there and then your answer. And remember, this is how you'll be doing your work on your test. So let's start here with number 23. A shipping company charges a cost per pound plus a fixed fee to ship a package. The total cost, f of x in dollars, of shipping x pounds is modeled by the function shown. So here's your function. Your variable is x, and in this problem, x is for number of pounds, and then f of x is the total cost. Which part of the function represents the fixed fee? Now remember, folks, if something is fixed, it is never going to change. That also means it's the starting point. Okay, now you know that a linear equation looks like this, and this is my y-intercept, or where I start. So if you take a look there, the y-intercept is that 5.75. That is our fixed fee, okay? It does not have a variable on it, and that's why it's fixed. If it has a variable, then obviously, depending on what that variable will be, that will change. So it would cost you $5.75 just to get any package to ship. And then obviously the $4.99 out front is dependent on how many pounds you have because it has the X on it. All right, number 3, to start her collection of comic books, Joy Lynn's uncle gives her a box of comic books and several monthly subscriptions to comic books. The number of comic books in her collection Y after X months is modeled by the equation shown. So here's our equation. They're telling me that X is the number of months and the number of comic books in her collection is Y. What does a number 40 represent? Well, you should notice this again is linear. The highest power on anything is a 1. So, therefore, I can rewrite it in y equals mx plus b form. Right now, it's in the wrong order. And it looks like that. Okay, I want to know what this 40 represents. Well, that looks like my starting number right now. That's my y-intercept, which means that's how many she should have before any month. So that's probably the number of things that her uncle gave her in that box. Okay, so first one says the price of a comic book subscription. No. The number of months of Joy Lynn's subscriptions, no, months is X, and that 40 doesn't have an X on it. The number of comic books in the box she received, that would be her starting number of books, and the number of title subscriptions Joy Lynn received each month. Again, this says month. That means it has to have an X on it, and the 40 does not. So your answer should be C. So both of those questions, folks, just require you to realize that that is y equals mx plus b form, and you have to know what each part is. Remember, the b on the end is our y-intercept, or our starting point, and the m with the variable on it is how much it goes up or down by every time. Number 27, the graph of a function is shown. What is the average rate of change between x equals 10 and x equals 14? Okay, between x equals 10 and x equals 14. Okay, well, average rate of change, folks, that is fancy for the word slope. Rate of change is slope. Slope is however much it goes up and down by every time. This is definitely linear, which means the slope never changes. Okay, it goes up and down by the same amount every single time. Okay, so we need to determine the slope. this x equals 10 and x equals 14 doesn't really have anything to do with it because, first of all, 14 would be over here. So that's not even on the graph, but we know it's linear, meaning the slope never changes. So they've given me these 2 points. All I need to do is find the slope. Now there's 2 ways to do slope. You can do rise over run, or you can do your formula, which looks like this. I would actually recommend just counting rise over run. So if we count this, we're rising, remember we always start at the left-hand point, we're rising 1, 2, 3, we're running 2. So my slope is 3 over 2. That's the average rate of change. It doesn't change at all, folks, because it's a line. If that would change, that means it would not be a line. So if I look again, up 3 over 2, and it would keep going. Okay, so your answer here would be 3 over 2. If you wanted to make it a decimal, it'd be 1.5. I wouldn't recommend it because remember, slope is supposed to be a fraction, or a whole number for that matter. Okay, which graph shows a 0 rate of change? Well, we just talked about what rate of change means. Rate of change means slope. So I need something that shows 0 slope, meaning it's not going up or down at all. And I don't know if you remember us talking about this, but I talked about how the word horizontal has a Z in it, and 0 starts with a Z. So a horizontal line has 0 slope or 0 rate of change, which means this answer would be A. Okay, moving on to number 11. The graph shows T, the temperature of water in degrees Celsius in a test tube after m minutes of an experiment. So if we take a look here, m minutes of an experiment, that's down here on my x-axis, and then T is the temperature of the water, that's here on my y-axis. Drag a label to each box to correctly identify the type of rate of change between the temperature and time on each part of the graph. So, you have these choices right here. We just learned, or we just remembered, that 0 rate of change means horizontal. Constant rate of change, what does constant mean? Constant means it never changes. Well, if the rate of change never changes, that means it's a line. Okay, now you also should know what quadratic means. Quadratic means highest power of 2, and that's a U shape. And then exponential means that it has an exponent on it. Okay, so if I want to put something here in this box, what type of rate of change do we have here? Well, that's horizontal. So I would put a 0 in there. And down here, what does this look like? That looks like a line, which means it would be constant. And you would be dragging and dropping those boxes into the appropriate spot. Okay, moving on to number 12. We have Brian and Tim both riding their bikes at a constant speed. Remember what constant means. Constant means it's a line, there's no change. And leave from the same location. Brian's ride times are shown in the table. So here's Brian. They tell me Tim rides faster than Brian. Which graph could represent Tim's bike? Well, if I want to know about Tim, I got to know about Brian. So I got to find Brian's speed. Well, speed is a rate of change. Speed is a slope. So I've got to calculate slope. And you have a formula for slope. And it looks like that. So let's go ahead and maybe just use these 2 points. This will be my x1, x2, y1, and y2, and let's plug it in. So my y2 is 2 minus y1, which is 1, over x2, which is 16, minus x1, which is 8. So I have 1/8. That is Brian's speed. Now, Tim is supposed to be faster than Brian. So I need to figure out which of these slopes are faster than 1/8, which means bigger than 1/8. So let's take a look here. We've got some graphs. Now remember, if I'm going to look at a graph, I got to find a nice point. Well, if I look at letter A here, it looks like there's a nice point right there. So we would be going up 1, over, looks like 8. So this would be 1/8. Well, that's the same as Brian, so that's not Tim's speed. Let's take a look at this one. It looks like there's a nice point right here that would be up 1 over 9. That's 1/9. 1/9 is smaller than 1/8, folks, so that's not Tim's speed. Looking at part B, it looks like I've got a nice point right here. That's up 1 over 6. 1/6. I think that would be bigger than 1/8, so this is a possibility. And let's go over here to part D. My nice point looks like it's over here. That would be up 1 over 10. So, yep, it looks like part B would be Tim. That is faster than Brian. Remember, Brian was 1/8. All right, number 10. Which graph represents a function that is decreasing at a non-constant rate? Non-constant means changing. That means not a line. Okay? Decreasing means going down. So which of these are going down? Well, this one is not going down. That B is going down. C is going down. D is going up. You see here, remember we're reading these from left to right. So my choices right now are C and B. Remember, non-constant means not a line. So the one that's not a line would be choice C. And that would be my answer. All right, moving to number 13. Kim is driving from Miami to Key West. The graph shows her distance from Key West. During what interval is she driving the fastest? So fastest means it better be steep because we would have a large slope or a high rate of change. So where is she driving the fastest? Where is it steepest? Well, this thing looks steepest to me from there to there. So I need to make, we'll take a look at this. This is a compound inequality. The x is going to be between those two numbers. So what two numbers would Kim have to be between to be driving her fastest? Well, we're between 0.5 hours and 2 hours. So you would be dragging those into the appropriate boxes. Number 9, the graph of line M is shown. What is the equation of a line that is perpendicular to line M and passes through this point? Well, the first thing you need to know is what's perpendicular. Perpendicular means a 90-degree angle. And in order for us to do that, we have to have opposite reciprocal slopes. So I got to figure out my slope here. Well, if I've got a graph, I can just look at it. Remember, I start at the left-hand point. I have to rise 1, 2, 3, 4, 5 down, which would be -5. And I'm running over 2. So that's my slope right now. I need to do the opposite reciprocal of that. Well, the opposite means make a negative turn into a positive. So now it's going to be positive 5 over 2. And reciprocal means it flip it upside down. So it would be positive 2/5. That would be my slope. Well, folks, I need an equation, which means it better look like this. So this is my M. They give me this point right here, which means I can use that as my X, and this is my Y. And then I just got to plug it in to find the B. So my Y is 2 from that point equals my M that we just found times the X. And I don't know the B yet. So we need to multiply here. 2/5 times 3 is 1 1/5. Then we're going to solve for B, which means we're going to subtract 1 1/5. And I will get 4/5 is B. Now I'm ready for my final answer. Y equals my M, X, and the B we just found. All right, let's do another one like that. Create the equation of a line that is perpendicular to that equation and passes through this point. Well, this is my point. This is going to be my x, and that's going to be my y. I need to find the slope of this line. Well, I don't know the slope in this line until it looks like this, which means I got to isolate the y, which means I need to divide everything by 2. So I have y equals 7 plus 1/3 x. Now that's not in the right order, so I'm going to switch it around. This is my slope. For perpendicular, I need to do the opposite reciprocal. So the opposite would be negative, and the reciprocal means flip it upside down. 3/1 would just be 3. So there's my slope. Now I'm going to plug it all in to find the b. Remember, this is what I want it to look like. My y comes from that point. The m is now -3. The x comes from that point. And I'm trying to find the b. Multiply and isolate. And now we're ready for a final answer. Y equals mx plus b. All right, a couple more to go today. Number 14, the function f of t equals -16t squared plus 20t plus 4 gives the height of a ball in feet t seconds after it is tossed. So right off the bat, t stands for seconds. The function tells us the height. What is the average rate of change? Folks, we are finding slope. You have a formula for slope. If you want to use this formula, you have to have 2 points. Well, they tell me the seconds right here. So I have to plug in those seconds to the function to figure out what the y would be. So let's plug in the first one. And you should do this on your calculator. And when you type that in, you should get 10, which means the point would look like that. So this is going to be my x1 and my y. Oops. And my y. My y. Y1. Okay, let's do it again. Now I have to go back up and plug in the other set of seconds they gave me, which is 1.25. So we're plugging this in for t because they told me it was seconds. Type that into your calculator, and you should get 14. So that means the point looks like that, and this will be my x2 and my y2. All right, folks, that's the hard work. Now we're ready to plug it into our formula up here. So I have y2 minus y1 over x2 minus x1. The top would be 4. The bottom would be 0.75. Now, we can't leave a decimal in a fraction like that. Okay? If you divide that, you will get 5.3 repeating. Can't have slope that's like that, so turn it into a fraction. And there is your answer for the slope or the rate of change. All right, last one for us today. A table of values for function A and the graph of B are shown. So I have 2 different ones, folks, here. I have the table and I have the graph. It says create an equation. Well, if it's going to be an equation, it better look like this. For a third linear function with a rate of change, that's the slope, that is between the rates for A and B. So I got to find the rates for A and B. Well, A is a table, so I'm going to use my formula that we've used quite a bit today now. And let's choose, I don't know, just the first 2. So this is x1, y1, x2, and y2. So we have And the numerator, uh-oh, I think I did that wrong. Let's try this again. y2 minus y1. Now that minus is going to turn into a plus over x2 minus x1. And again, that's going to turn into a plus. So up top I have 4.5. On the bottom I have 6. So we're going to have to go ahead and divide that. 4.5 divided by 6 gives me 0.75. So that is function A. Let's look at function B. Now, this is a graph, so if I can find 2 nice points, I can just count. Well, there's a nice point, and there's a nice point. So let's do our rise over run. We are rising 2, we are running 5, so that's 2/5. So I need something that would be between these two. Well, this one's a decimal in red, and that one's a fraction in green. So why don't I turn the fraction one into a decimal? So now I just need to make an equation that has a slope that's between those two. You literally can pick any number that is between 0.75 and 0.4. I think I'll just pick 0.5. So I think my slope is going to be 0.5. Does it say anything about the y-intercept? It does not. So you get to pick whatever y-intercept you want to use. And there we have it. The only number they were concerned with was that slope being between function A and function B. All right, folks, so that concludes our review for today. On your mountain math, I would like for you to do a couple questions for me for homework. Let's have you do numbers 6 and 7 on your mountain math for homework. And we will finish the graphing portion tomorrow, and we will keep rolling along with that mountain math, getting you ready for your test, which will be May 4th. Have a good day, folks.